Hello. So I'm planning on building a very cool device that will keep track of air traffic above my house using Flight Radar 24 data and feed it to a cube of LEDs. And then that cube will, show you where the planes are and where they're heading over my house. Yeah, so let us hop into the Stang, go to Micro Center, pick up some tech, and let's do this. All right, we're here. So I think I'm planning on getting definitely Raspberry Pi 4 if they have it in stock. If not, I'll just go for a Raspberry Pi 3 because it has the Wi-Fi built in. I'm gonna need probably more than one breadboard, a crap ton of LEDs. Like, I'm gonna need 64, so I'm probably gonna get around 100 because those things short easily when you solder them. I might not even go for soldering, might just go for some crimping tools. And there's some dowels to set everything up on, and a whole bunch of wires, female, male connectors, everything. All right, so let's go in, let's grab it. Okay, here's some Raspberry Pi 3s. I'll probably be going with these since they're marked down. That is convenient, but I'm gonna look around and see if they have some 4s, and if they do, then I'm gonna go with those. Wow, this is a big wall. We couldn't find a crimping tool. He's gonna check in back. I hope we definitely can find it, because if we don't, it means I'm gonna have to solder, and I do not know how to solder. So, can't think of anything else I need. I think we should be good. We've got the LEDs, we've got a bunch of breadboards, we've got a bunch of wires, I have more stuff at home, resistors, soldering iron, so we should be good. Okay. Loud AC. Okay, so I bought all the stuff I need. I'm gonna head home and start planning it out. I also bought a tripod for this thing so that I can make a time lapse while I'm working. Yeah, let's see how this goes. All right. We're gonna set a small goal for today, or at least the next couple hours. Get Raspbian, which is the Linux operating system for Raspberry Pi, installed on this thing. And we're gonna make it blink an LED on the breadboard. And that's it for now. So let's do that. We're gonna wanna unpack the multimeter so we can install Raspbian on this thing. So, this is a Raspberry Pi 3. Here we go, here's the micro SD slot. So we're gonna pop this thing out. Let's just check to make sure that this thing actually powers up. Let's see if you power up. Yep, got power LED on, so this thing's working. So the monitor is powering the Raspberry Pi, and it's also serving as a hub for the keyboard and mouse. So this is the Raspberry Pi installer. Let's see if you can see that. There you go. Now this setup is extremely unideal, so as soon as possible we're going to get this thing on the Wi-Fi and SSH into it so I can use any of my devices to access it. Okay, so Raspbian finished installing. After a reboot, we should be able to mess around. Here we go, Raspbian. So I can see that the name of the computer is Pi at Raspberry Pi, so we can say SSH VVV at Pi at Raspberry Pi. And it's saying connection refused. Okay, that's probably because we need to open up a port or install the SSHD daemon. So let us go do that. So, aha, okay, so we are connected. And so for example, aha, okay, we are good. All right, so we have a full SSH access. So now we can revert back to the old system. Okay, so now that we've gotten Raspbian working, we can, let me just close, there we go. All right, we can SSH into it. So SSH, all right, Pi at Raspberry Pi, okay, yes. Oh, did I type that in wrong? There we go, okay, we're in. Okay, so we should be connected to the internet. Yep, everything's all good. So now we want to, we have this lovely little Raspberry Pi. We want to connect it to a breadboard and turn on an LED. So let's Google how to do that. Low. Okay, so now it should run it continuously and wait for us to press a key, and then it should turn it on. Oh, there we go. Cool. So we now have a little proof of concept. If I hit enter on my keyboard, if I can pull it up, the LED lights up. Next up, we're going to want to control how bright it is. So I think I should be able to do that. So let's give that a shot. Can in fact dim the brightness of the LED using pulse width modulation, since an LED doesn't really dim like a normal light bulb. But that's actually less important. Right now I want to try a proof of concept thing. I want to set up an array of 4x4 LEDs, which will represent one layer of the LED cube in the end. And I want to see if I can control all 16 LEDs using just 8 ports. So what this is going to amount to is each LED is going to turn on. It's like a light bulb with 2 switches that are required for it to turn on. And the way I'm going to wire this is that I'm going to have it set up so that I can turn on one switch for an entire row and one switch for the other switch for an entire column. And that way at the end only one LED will have both switches on, and that'll be the one that's on. And so doing that, I can effectively I can turn on arbitrarily, an LED in a grid of 16 LEDs using only half as many ports. And that, that benefit grows exponentially, so when we turn it into a 3D cube, I'm gonna need 12 ports to control 64 LEDs. So we're gonna see how this ends up working. One of the problems is I have no idea how to make this sort of 2-pronged switch for an LED. So that's something I'm gonna have to be thinking about. Okay, so we got some stuff working. Basically, I wrote a script that you give it a port and it sends power to it. That way I can test each one of these individually in real time. So right now it's asking me for a port number. I'm gonna give it port number 22. So right now my port number 22 should be this one, and it's connected to the my test LED here. So if it lights up, I know that's working. But I do not think it's connected. Yes, it's just connected there. It's not connected to anything else yet. So if we give it 22, this LED should light up for a second. So that's working. Now, we're going to test on one of the parallel ports. I've only put these two in parallel so far. So I'm going to test this port here, which should be port 17. This port goes into this column right here, which passes through this resistor before it gets to these two LEDs, and they're in parallel, so they should light up the same brightness. So let's give it port 17, and boom. Alright, so now I want to test these two, which I'm unsure if I've connected yet. So it's this port. Let's give it port 27, and now these two LEDs should light up. Okay, so that's step 1 working, and now I've got to connect these two in parallel so that I can turn on port 17 and port 22 at the same time, and one of them will be brighter, basically. Hopefully, that's the hope. Alright, another time lapse coming up. The thing arrived. This is the wideband radio frequency receiver that will let me spy on planes overhead. let's open her up. Let's open her up, figure out how to use this thing. So this is obviously the antenna. It attaches via some sort of serial port, which I'm guessing plugs into this thing on the side of the Raspberry Pi. So now we got the documentation. So let's see how we set this up. Okay. So now we have to, okay, so first thing is we have to install the software for this thing on Raspbian. Okay. Is this the stick I'm supposed to use? I have no idea how I'm supposed to use this. Oh, it's a USB stick. Oops. What is this port? Oh, maybe this goes in here. Oh, yeah, I think this goes in there. Okay, that makes sense. Now we've got our nice little setup. Okay. We're gonna try this one more time. Alright, so we've got it connected up to the Raspberry Pi and everything has been installed. It is now reading data into port 3000 and 30,002 on the computer. So I'll be able to read that and then apply it to the LED cube that I'm building. And we're going to use this. We can see that the planes it's seeing around us. It seems to have a pretty good range, about 100 or so miles. So it's seeing quite a bit of planes, and it's basically getting most of Logan right now. So yeah, this is some pretty cool software. All right.